Hello, my name is Oleg Tinashev. I'm a member of Gradle DevRel education team, and today we are happy to present the new major release of Gradle build tool. This is a 9.0 release. Gradle 8.0 was shipped around 2 years ago, and since that we've delivered a lot of improvements for Gradle users in minor versions. You might be watching this video before the final release. We tried to ship it early, and if you see the release candidate, we encourage you to try it out and share your feedback using GitHub Issues or Gradle Community Slack. In this release, we made configuration cache the recommended execution mode or the preferred execution mode. It means that we encourage people to start adopting it. Java 17 now is the minimum version to run Gradle or Gradle Daemon. You still can build all the projects using the toolchain, but Gradle keeps updating and adopting new features of Java. Same, we updated to Kotlin 2.2 and Groovy 4.0, so there are new syntax, new performance capabilities, and one of major changes is Kotlin build script compilation avoidance, which greatly increases build speed in certain scenarios. As always, there are more minor features added here and there. There are many deprecations, removals, including in this release. Check out the full video if you watch the short. As you can see on the slides, I have 9.0.0. While I keep saying 9.0, in fact, Gradle build tool adopts Semantic Versioning and SemVer specification 2.0. It's an open standard which is used in many projects to specify particular compatibility changes. Keep in mind that internal APIs and incubating features do not follow specification and may change at any time, but all stable features and all features we promote, they follow this versioning. And of course, we got some features like being able to select by minor version in the Gradle Wrapper. To learn more about the release and the features available there, check out the Gradle 9 release page. There we aggregate all the changes between 8.0 and 9.0.0. You can see that there is quite a lot of changes, summaries, demos, and references. So if you are just starting with Gradle 8 and Gradle 9, it's probably the best source of information for you. If you keep up to date with recent minor releases, then you can go to the changelog. In the changelog, we have the summary for this release, including all the features. Of course, we have upgrade instructions. There is also information about API removals, deprecations, and everything else that we normally provide in the releases. Last but not least, there is upgrade guide that will provide all the necessary information about the potentially breaking changes. Of course, we update the Java version or Kotlin version. There are potential consequences, including source incompatibility or binary incompatibility, and this is something you need to keep in mind. So when you upgrade to Gradle 9, please consult with upgrade guidance. We have quite a lot of information and references for particular steps. For now, let's proceed with particular features that we introduced in 9.0.0. And the first one is of configuration cache. I will hand over it to Alex, who can do the presentation.
Configuration cache gets a couple of updates in Gradle 9, and we're also making it the preferred mode of running Gradle. As a quick primer, whenever you run tasks, Gradle does a couple of things. First of all, it looks at the structure of your build on disk and figures out what the projects are there. Then it configures the projects to find the tasks you requested, and later builds the work graph that defines the actual work that's going to happen during the execution to provide the results you requested. When you run with configuration cache, Gradle also tracks any build inputs that are being read during configuration so that the work graph that is being produced could be cached and later reused. When you later run the same tasks again, with configuration cache, you can skip the configuration phase entirely and go directly to the execution. This is one of the main benefits of configuration cache, and this is why we're very excited for it to be used by more users. Configuration cache became stable in Gradle 8.1, and since then we delivered the continuous stream of improvements in the areas of reliability and usability to make adoption of configuration cache as easy as possible. As it reaches this level of maturity, in Gradle 9 we are making it the preferred mode of running Gradle. And we have a goal of enabling configuration cache by default in Gradle 10.
So, what does preferred execution mode actually mean to Gradle 9 users and adopters? What updates are needed? I'm handing it back to Alex.
Configuration cache gets a couple of updates in Gradle 9, and we are also making it the preferred mode of running Gradle. Gradle 9 major release serves as a great opportunity to put the message out there while also leaving enough time for everybody to adopt. As part of that, we're going to promote configuration cache in the builds themselves. When appropriate, we'll show a message that encourages the usage of the configuration cache. We're also making sure that whichever core Gradle plugins you're using, they're going to work with configuration cache, meaning that you won't see any build failures when using them regardless of the scenarios. After Gradle 9 release and in the timeline of the Gradle 9x releases, we're going to continue improving the hit rates of configuration cache such that you get the improvements more frequently in your workflows. We started removing some of the old incompatible APIs in Gradle 9, such as the project exec callback, for which now there is safe and idiomatic alternatives already available, such as exec operations. During Gradle 9x timeline, we plan to deprecate all incompatible APIs with the goal of removing them in Gradle 10, making the experience with configuration cache as seamless as possible. Now for a short demo. We are running Gradle 9, and we have a really simple build setup. We have a simple task that only prints some things. When we run this task with Gradle 9, now there is a message that encourages the users to try out configuration cache to speed up the builds in some cases. However, if there was a problem with a build, we would not display the message because we know it would be unsafe to migrate immediately. For instance, if we take this example of unsafe access project at execution time, if we run with Gradle 9, in this case, you won't see the promotion message, but you'll also notice that access to this API, such as the project at execution time, is generally deprecated as part of our commitment to only have the APIs in Gradle that are compatible with configuration cache. There were more improvements to configuration cache in Gradle 9. For instance, when we run with configuration cache, before Gradle 9, Gradle would execute the task in its entirety and later on report on this problem, such as the unsafe access. And you would see the project demo being printed. However, with Gradle 9, now we fail the task immediately, avoiding the mistake of having to resolve problems that were induced by access to that unsafe state, but really don't exist. So in this case, you can see that we only print the initial line, but before we get to printing the second one, the build actually fails with a problem that describes exactly what happened. With configuration cache becoming the preferred mode of running Gradle, Gradle 9 becomes the best time to adopt configuration cache and get the benefits. As the benefits are not only significant from the configuration cache itself, but it also serves as a foundation for upcoming features that make Gradle even faster and more scalable. Configuration cache is an important part of the Gradle future, and we have a goal of enabling configuration cache by default in Gradle 10.
Thank you, Alex. If you're interested and if you want to start with configuration cache, check out our user guide. We have a special page dedicated to enabling configuration cache, which shows how to set it up, how to get started. Also, there is a special guide for adoption, including how to troubleshoot common issues, how to actually develop features in your build scripts and plugins. So follow these guidelines and all the referenced documentations, and you will be able to adopt it quickly. As always, we appreciate any feedback. There is a GitHub issue about compatibility of configuration cache, and we would appreciate if you report any discovered incompatibilities so that we can improve the ecosystem and work with maintainers to actually get their plugins compatible. Thank you. And the next item is upgrading to Kotlin 2. We will talk about upgrade itself, about Kotlin build script compilation avoidance, and the potential breaking changes this upgrade brings to users. Louis, the floor is yours.
Gradle 9 comes with a pretty major upgrades of the embedded Kotlin. In Gradle 9, we now use Kotlin 2.2. This is both for the runtime, but also for the language level. So this is quite a change compared to the 1.8 language level that was used in Gradle 8. We also adopted all the Kotlin 2 goodies, such as the K2 compiler toolchain for the build logic. Note that we do not expect the full benefits of the K2 compiler performance improvements, because Gradle's Kotlin usage means that we often compile a single build script multiple times versus K2 shining in compiling larger sets of sources altogether. However, the fact that we use those versions enables build author to leverage the Kotlin 2 features we're targeting Gradle 9 and above. And it allowed also Gradle implementation of compilation avoidance for Kotlin build script to be replaced by compilation avoidance from the Kotlin team. As we can see, this can have pretty serious effect on your compilation time for build logic, because one of the lackings we had in the Gradle implementation was whenever you had Kotlin inline function, we would have to recompile everything always. And for example, the Kotlin implementation is much better with regards to that. What it enables also for the future is that any improvement the Kotlin makes to compilation avoidance, Gradle users will benefit immediately through upgrading Kotlin inside Gradle. Enjoy the new Kotlin features.
Thank you, Lou. One thing to always keep in mind when upgrading to major versions, including this time Gradle 9 and Kotlin 2, is potential breaking changes. If you open Gradle upgrade guide, you can see that there is a section for upgrading to Kotlin 2 that references the main changes and also points to Kotlin release notes, where you can find a lot of information. For more information, also refer to Kotlin release notes, and specifically there what's new pages that are available on Kotlin documentation. For example, for 2.0 and other versions, you can find summaries of breaking changes, including syntax ones, and you can follow that if you hit any issue in your build script. The same for other versions. So the last version we have is Kotlin 2.1.20. All the changes between them, and you should be fine. Thank you, Laura. Adopting Kotlin 2 also allowed us to complete another project we've had for quite a long time, improving nullability annotations in Gradle APIs and hence making plugin and build script code null safe and more easier to develop. Let's see what is inside.
Gradle 9 comes with changes around the way we handle nullability in the Gradle APIs. Since Gradle 5, we've been using GSR 305 annotations on the public API to allow early detection of nullability issues, both in the Kotlin DSL and for plugins written in Java or Kotlin. The semantics were limited, we had corner cases, and also the GSR has been dormant for a while. With Gradle 9, we're adopting gspecify annotations, which gives us better semantics. They have the same scope and benefits, but we have effectively those extra cases that are covered. And also there is a deeper integration with Kotlin, and especially with Kotlin 2 and above. And so we've done a coordinated effort to use them properly everywhere on the whole public API, but this may have consequences on source compatibility of your existing build scripts or plugin code. You could get more warnings in Java and possibly some errors in Kotlin, both for DSL and plugin code alike. Some of the common breaking changes we've seen, we've had patterns of declaration of a provider where the type of the provider itself was marked as nullable, but this is not accepted because in property, in the Gradle property type, T is not nullable itself. What it is that you get an error if you try to access an empty provider, and you should instead check either if the provider is present or do a get or null or things like that. Similarly, a Gradle API that accepted a map string star parameter will not allow you to pass in null values. What happens for plugins out there that still use GSR 305? Well, they will just continue to work fine in Gradle 9 as they did in previous version. However, we would recommend plugin authors to adopt gspecify so they benefit from the enhanced semantics and the Kotlin integration.
So, Kotlin to update major performance boost thanks to compilation avoidance and also gspecify adoption. All of that already justifies Gradle 9, right? And it's quite nice from user point. But that's not all. We also have updated minimum Java version, which means Gradle will be running on Java 17 and means that some extra updates might be needed. I will let Sterling explain the change and what's inside.
We're also making changes to the minimum requirements for running Gradle builds. In Gradle 9, the Gradle build process, or the daemon, requires Java 17 or newer. Gradle still supports running compilers and tests and workers all the way back to version 8. You can select different versions using JVM toolchains. Here's an example configuring a build to use Java 11. This means that the Gradle process itself will use Java 17 or newer, and the compiler will be using Java 11. If you try using an older version, Gradle will fail to start the build and tell you to switch to Java 17. You should consider using Daemon JVM toolchains to select which version of the JVM you want. This is really helpful if you have multiple versions of Gradle and you need to switch between different versions of Java for compatibility reasons. This feature can also automatically select the right JVM or provision a new one if it's configured to do so. For plugin authors and tool integrators like IDEs, TestKit and the tooling API remains compatible, but you need to be sure to start the build under test, the build that you're starting through the tooling API with Java 17 or newer when you're using Gradle 9. This doesn't include the Project Builder API. That API requires Java 17 since it's running the Gradle runtime in process.
To sum up, we are upgrading runtime to Java 17. You can still build your projects with older versions of Java with help of toolchains. Okay, let's go ahead, and we are also upgrading Groovy from 3 to 4.
I have a couple big changes to Gradle 9's runtime to tell you about. First, the embedded version of Groovy is moving from Groovy 3 to Groovy 4. You may be using Groovy if you have build.gradle build scripts or rely on local Groovy as a dependency. We don't expect most build scripts to require changes, but we have some more specific details in our upgrade guide. Groovy 4 is mostly compatible with Groovy 3. Plugins written with Groovy 3 usually work with Gradle 9, but some require new releases. Plugins written in Groovy with Gradle 9 may not be compatible with older versions of Gradle because of the version change. If you're writing plugins with Groovy, we always recommend that you compile with compile static because that compiles closer to regular Java code. That's faster and more reliable across Gradle versions.
Thank you, Sterling. Another thing we are working on continuously is improving supply chain security for everyone who uses Gradle to build their projects. And effective Gradle 9.0.0, we're enabling reproducible archives by default in all builds. I will let Andrzej explain what it means to the users.
With Gradle 9, we enabled reproducible archives by default. This is a big step towards reproducible builds, but it's only a part of reproducible builds effort. What has changed? We changed the default Gradle core archive task configuration. Archive tasks now produce reproducible outputs. File order in archives is now deterministic, files have fixed timestamps, and file and directory permissions are fixed. As a result, archives are byte-to-byte identical across different environments, and this change improves the reproducibility of builds. This configuration is applied to tasks that extend abstract archive tasks, like zip, jar, and others. It's important to note that this is a breaking change. If your build relies on file order, file system timestamps, file system permissions, or file executable bit, you may need to adjust your build configuration. You can adjust configuration by configuring tasks directly. For example, you can restore to the previous behavior of archive task with a configuration like shown in this slide.
We also have a number of quality of life improvements that were delivered in Gradle 9.0.0 release. The first one is ability to reference current project in the attached configurations.
Starting in Gradle 9, detached configurations can now resolve to the current project. Consider this example where we create a consumable configuration and a detached configuration with the same attributes, where the detached configuration has a dependency on the current project. In Gradle 8.14, this would improperly resolve the dependency to the detached configuration itself. In Gradle 9, the dependency is properly resolved to the consumable configuration.
The next one is being able to use Java Home as a toolchain provider in Gradle Daemon.
With Gradle 9, Java toolchains are now able to use the Java Home as a toolchain location. So here we've got a project with Gradle 8.14.2, and that project, as we can see, fails to build because it requires Java 20 to be available. And there are no Java 20 to be auto-detected, and auto-provisioning has been disabled for this illustration. We do have a local Java 20 installed, and what we're going to do is we're going to point our Java Home environment variable to that location. Once we've done that change, we can rerun the project, and even with Gradle 8.14.2, it works properly because, as shown by the Java toolchains task, the Java 20 is actually detected as the JVM that is running the daemon, and so it's the current JVM And so it is usable by the toolchain subsystem. And so this is done because we have that Java Home property set. Now, if we try to do the same from the IDE, the problem is that the IDE has its own environment and doesn't know about Java Home. And so when we try to run the test, we can see that they fail because, again, a JVM that has language version 20 cannot be found. What we can do is we can edit the test configuration and pass in our Java 20. But as we can see with Gradle 8.14.2, this doesn't work. Now, if we upgrade the project to use the Gradle 9 release candidate, we can see that the wrapper is updated. And if we rerun the test from the IDE, this works as expected. This is because the Java Home property of an environment variable, which is passed to the Gradle execution environment from within the IDE, is now properly leveraged by Gradle. And so Gradle is able to resolve a Java 20 toolchain. However, there was a second bug fix made in Gradle 9, which helped with the passing of the Java Home, of the general environment variables, because in prior versions of Gradle, environment variables passed here would be ignored, at least in the context of the daemon toolchain, so as a way to start your Gradle daemon. And so Gradle 9 also fixes the additional bug. Yeah, so thank you for listening, and we hope you enjoy the increased feature sets of Java toolchains.
And the last improvement that may help all users is support for semantic versioning and symbolic names in Gradle build wrapper.
9 got some updates related to versioning, as you may have already noticed. Starting with Gradle 9, releases will follow semantic versioning specification. Previous releases were almost compatible with it already, and the last missing piece was version numbering. This unlocks a new potential for version selection. In existing versions of Gradle, it is already possible to select the latest released version of Gradle for wrapper using the corresponding keyword. However, in some scenarios, it is not flexible enough. So let's just imagine that we have the following versions released. We are talking about 9.0, but let's imagine there's a Gradle 10 as well. So Gradle Wrapper latest will give you Gradle 10. However, if you have a lot of build logic, you can be cautious about breaking changes. You can type 9 to get whatever the latest version with major version 9. In our example, you'll get 9.11. And similarly, you can do the same with 9.0. And you get a latest patch for that minor. Not that this logic only applies for Gradle 9 and later, because it would be confusing or ambiguous for 8.14, whatever we call for 8.14 or 8.14.2, the latest patch. And of course, all of that above applies as saying to the logic defined in task definition. So you can write it a declaration in task and get whatever the latest version for 9 as well.
Thank you, Vlad, and thanks to everyone who presented today on the features. Another item that we normally do in the releases is promoting some features. And also, since a major release where we can allow for some compatibility breaking changes, we introduce some removals and deprecations. For everything, please refer to upgrade guidelines, change logs. For example, for promoted features, we have multiple Kotlin DSL operation functions, including assignment operator that is introduced. You can also do dependency constraints and handler APIs in DSL now. There are more minor features here and there that got promoted. For removals, we removed a lot of deprecated APIs. Like Alex said before, it's mostly about configuration cache compatibility, and most of APIs have better replacements as of now. For all deprecations and removals, please refer to the upgrade guide. We have a full list there. You can just see what we removed and what is a potential alternative there if it's available. Another specific item to mention is convention removal. So convention was an old API that actually existed since Gradle 1.0. And it was a secondary container for many elements like projects, tasks, source sets. So going forward, this API won't be available, and the reason is quite simple. It was a Groovy only feature, and now we have a better mechanism called extensions that actually provides a full replacement for that. Okay, that's it for today, and thanks a lot for watching. Just to reiterate, to get started, check out the Gradle 9 release page. We have all the information and references there. Also, we have release notes that covers Gradle 9.0.0 changes specifically, including all the features we presented today. Then we have upgrade guide that describes potential compatibility issues and migration paths. And you can also find many demo videos on our YouTube channel, including this one. For more info, as always, we have a public roadmap. We also have a newsletter. Make sure to subscribe. Every month we have new updates from the Gradle community and ecosystem. One highlight I would like to mention is the new resource called Gradle Best Practices. This is a part of our documentation. It was introduced in 8.14, but since we skipped the release, I would like to ask Laura to do introduction for this resource.
Gradle gives you flexibility, but without clear guidance, it's really easy to create an unmaintainable build. That's why the folks at Google, JetBrains, and Gradle teamed up and published the first ever Gradle Best Practices. These best practices are here to help you build on a stable, modern foundation that works across all of your projects. You'll see some new pages starting with Gradle 8.14, and you can navigate to any of these pages like the best practices for dependencies, where you will see a best practice has a title, a detailed explanation, and usually a code snippet as well. This helps you decide whether or not this best practice applies to you. This is just the beginning. We will keep evolving these best practices based on your usage, your feedback, and many more expected to come with Gradle 9.
Thank you, Laura. And again, thanks everyone who presented today, and thanks everyone who contributed to Gradle 9.0.0 release, all the previous 8.x releases. We will appreciate any feedback on Slack, on GitHub Issues, on documentation, and that is a dedicated feedback form. Keep using Gradle and updating to the latest and greatest versions. So let's see what's 9.1 brings in. If you have any questions, consider joining our Slack channel, and we will be happy to answer all the questions in the releases discussions channel on this Slack. Thank you, and see you soon.